to another video, guys. You're on Physics with Daniel Dallas. We continue exploring electricity. Today target is to explore mobility. As you remember, we reached the idea that the drift velocity of charge carriers in different substances in different states, obviously depending on electric field strengths, just by applying basic principles of and applying the second Newton's law, we understand that there is the force of interaction between ions, and hence we have an average drift speed of electronic gas in metals or ion gas in liquids and gases. And today we are going to explore the term mobility. So basically the effects of the drift velocity depending on their external electric field. So this is sort of coefficient, and there is the sense to talk about average mobility for positive negative ions. So that's why this concept also can be applicable to electrons as well, because we can explore mobility of any charged particles. But I start my consideration with exploring gases, and you understand that generally gases are non-conductors, but under specific circumstances like external radiation like X-rays or UV, high frequency radiation, it makes your gas as good conductor because this radiation will form positive and negative ions, and this concept we considered before. So today primary purpose is to explore mobility. Basically, we set up the question how the drift velocity is depending on external electric field being applied. So that's why we connect this gas tube at normal temperature. It might be a rarefacted gas, but like you have in a gas tube nowadays. But the general principle that we are going to explore, we just apply mechanics, classical mechanics. Okay, so we plugged positive terminal here and negative terminal here. So in gas tube, and for example in CRT, cathode ray tube, however, there is a high vacuum inside. So right now we are not going to explore vacuum, but rather we explore gas. So in those cases, what I mean that those types of electrodes are called anode, that's positive one, and cathode. Okay, and if we plug, we will create the electric field strength inside. So that's going to be an electric field here. So we mark SE, and we just consider random ion. Let it be positive ion. For some reason, I just don't want to have deal with negative particles. Obviously, it will be experienced the force. So that's going to be the force due to electric field E, which can be written as through electric field strength and the charge. So obviously, instead of E, we can use the general charge Q of this ion because we don't know in advance how many electrons were torn off due to process of radiation, and hence generally set up Q as the charge of this ion. Of course, there will be different ions, but in average, we can take the effective charge. So Q will be effective charge of this ion. All right, so due to the fact, and right in the second Newton's law, to this charged particle, we can state that effective mass of this ion times acceleration will be proportional to EQ. So acceleration is change in velocity, so that's why we can write through the change in velocity over time. And the right hand side of this equation will look like Q over m times E. Okay, so right now we can integrate, and that means we have basically velocity between two consecutive collisions from some starting point to the final one. Let's assume that initial velocity is 0, so we are going to find out the final velocity here after right before the second collision. So that's the first collision and this is the second one. So in between, for time delta t, so change in speed is going to be up to drift velocity, and hence we need to integrate q over m e and delta t. All right, so we are going to integrate that. Obviously, electric field might be non-uniform, but for simplicity, we assume that we'll have uniform electric fields. And in this case, we just arrive to the following, so that we have drift velocity is proportional to electric field strength with some coefficient that you have in just before as the factor. So this coefficient that depends on the effective charge, on effective mass, and delta t, where delta t is the time between consecutive collisions. So an average, of course, for any particular ion is going to be a different value, but in average, we can state that this amount is going to be some effective tau time that's specific for a particular substance or for particular pattern, for particular gas. So this coefficient we would call the mobility. So mu, it's not molar mass, but we use the same like Greek letter so that we can rewrite our equation for drift velocity as mu times E. Of course, that was done for positive ion, but in the same way it can be done for negative ions as well, so that we can write and apply the same principle here. But definitely mobility coefficient will be different depending on mass, right? And that means you need to separate mobility for positive and for negative particles, charged particles, ions. Hence, we better write and split them apart. And of course, if we're talking about negative particles, negative charged particles, the drift velocity will be against the external electric field. So those formula that we got will be very useful, and in most cases you'll be given mobility by fabricant facility that you use. So electric field you apply is your input data, so you can change electric field, and hence you every time you can calculate the drift velocity. So basically, using electric field strength as input, you can calculate the drift velocity, while mobility will be given by producer of the substance. And as you understand, so we rely on average time between two consecutive collisions. That's going to be a factor of a given concentration of your gas or whatever substance you have. So that's the main fact. It's very useful, and we need, of course, to bear in this formula in mind in order to apply them somewhere during solution. So having this formula, we move to the next step, and in the next video we'll discuss the origination of the Ohm's law, first in differential form and then into classical form for the part of the circuit. So I'll be talking about I equals voltage, or U, or V, let's say V, voltage over resistance, and find out how it can be how it can be done, how this formula can be derived using those micro principles. All right, stay tuned up and see you next time.